So till here I think it is clear. Okay, ma'am? Means if beta
Yes,
is
sir,
equal
clear.
to, yes. So today we will be doing constant elasticity function. So as already we know, an elasticity is a ratio of
Marginal to
proportional changes, right? Ratio of proportional change. So it is a unitless measure of sensitivity. So it is easiest to interpret in terms of small percentage change. Suppose for example elasticity of y x. So it is basically percentage change or percentage delta y or change in y divided by percentage change in delta x. If you will divide, you will get elasticity, right? So suppose for example if the price elasticity of demand equals to -2, then percentage change in delta y will be equal to -2 into percentage change in delta x. And if you will take percentage change in delta x is equal to 1, then the interpretation will be a 1% increase in price x leads to a -2% change in quantity y. Madam, is it clear?
Yes, sir, clear.
Chinmay?
Yes, sir.
Sangeeta?
Again, sir.
Okay. So a function which incorporates a constant elasticity relationship is y is equal to a into x to the power beta. So here the slope of a into x to the power beta will be little complicated. So it will be like beta times a into x to the power beta minus 1. Now whether this function can be transformed into a linear relationship. Bhakti ma'am?
Yes, sir.
Okay. How we will do it? Using ln.
Using logarithm?
Logarithm, yes. So the slope is different at each value of x, but the elasticity is constant.
Constant.
So delta ln y is equivalent to delta y upon y divided by delta x upon x. Okay, ma'am? Simple.
Yes, sir.
Beta, when we write delta y upon delta x, please try to see the difference. So this is different than when we are writing ln, because it is proportional change. Okay, ma'am?
Nice, sir. Yes, sir.
This is proportional change.
Yes, sir.
Means it is y2 minus y1 upon y1.
Y2.
y1. And this is also x2 minus x1 upon x1.
Next one.
Okay? So now you just see, you have taken a constant elasticity function y is equal to 10 into x to the power minus 2. So you can plot it in Excel. Okay?
Yes, sir.
And third is, what you can do, you can take ln as Bhakti ma'am told, ln of 10 to the power x minus 2. Right, ma'am?
Yes, sir.
So it will be ln 10
minus 2 ln
minus 2 times ln x. Sangeeta, is it clear?
Yes, sir.
Very good. Now you have to draw this. Means you have to take the different values of x. I think because x values are maximum, it is not given. We can take 1, 2, 3, right?
Yes, sir.
Because for y value it is defined, right?
Yes, sir. But x value can randomly. X is the independent variable here. So
So
we can choose any value.
here they have taken 0, 2, 4, 6, 8, 10 like that. You want me to plot it or you will do it?
We will do it, sir. We will do it.
Okay. So now last section is the interpretation of proportional change using natural log. So when you have a model like this, ln yt is equal to beta naught plus beta 1 t. Okay, so beta 1 gives us the continuous proportional change for unit t. T means maximum, it is time period basically.
Yes, sir.
Means for example, let's say that yt is your GDP, right?
Nice.
You have GDP data for various years. So year is your T.
Right, sir.
Okay, ma'am? And
Yes, sir.
your GDP is YT. So Y 1, 2, 3, 4, let's say that for different year you will be writing like this. And then your GDP you will convert into ln. Then you will get this equation. Then you can estimate it. Is it clear, Bhakti ma'am?
Yes, sir. Clear.
So the continuous proportional change is different from the simple discrete proportional change that we are familiar with. तो से कौन चीज मैम बीटा 1 होची continuous proportional change. Continuous proportional change which is different from simple discrete proportional change which I had written earlier. So this is y2 minus y1, okay, divided by y1. This is a simple discrete you can say simple discrete proportional change. But if you will take ln, it is continuous proportional change. Okay, okay, ma'am. Let us try
Yes,
to
sir.
understand how it is. Now the good news is that it is straightforward to convert from a continuous proportional change to simple proportional change using exponential function. If beta 1 is a continuous proportional change, then corresponding simple discrete proportional change will be e to the power beta 1 minus 1.
This minus 1 is also e to the power
No. It is outside.
or e to the power beta 1.
It is
Then
like this. E to the
it
power
is a
beta
term,
1.
then minus 1.
Madam, it is like this. E to the power beta 1.
Okay, okay, sir.
Okay.
Okay, sir. Okay. Okay, sir.
So, we will do it. We will see. One example we will do it. Now the question is, okay, so now why you will be using this formula? Bhakti ma'am? You will be using to
This is about discrete, to find the discrete proportional change.
from
From the
continuous
continuous
proportional
proportional change.
change, from continuous proportional change, if you want to convert into simple discrete proportional change, then you use this formula. So here the beta 1 is, you have got it through this
Continuous.
continuous proportional change. You are converting.
Ln yt.
Okay, well?
Okay, sir.
Suppose what you do, you can do this. Let us try to do this. Okay, here it is there. Formula in Excel, you can type it, not a problem. So suppose it is saying, let's say that y changes between values of 100 and 120. What is the proportional change? So with simple proportional change, the answer depends on the base chosen. If we are taking base as 100, then definitely our proportional change will be, as I told you, 120 minus 100 divided by 100. So that is 0.20. Is it clear, Bhakti ma'am?
Yes, sir. Yes, sir.
And if you are taking base as 120, then obviously it is changing, right? It will change to minus 0.1667. Clear?
Yes.
Now, if we take delta,
Log value, the base is not changing.
this is what.
Yeah.
So if we take ln values, that is continuous proportional change. So the answer is invariant with the base. Whether you are taking 120 fast or 100 fast, ln 120 or ln 100. So the change you can see over here, the answer is same, 0.1823216. Is it clear, Bhakti ma'am?
Yes, sir. Yes, sir.
Only minus is coming. That is fine, not a problem, because we are
No.
subtracting from a lower value to a higher value, na? So that is why.
Yes, sir.
Now you can always convert delta ln value to the equivalent simple proportional change. How? Because already we know 0.182. So e to the power 0.1823216 minus 1 will be equal to 0.20. And similarly this will be also this. Okay, ma'am?
Yes, sir. Yes, sir.
So continuous and simple proportional change are very similar when the delta ln value is near to 0. But they differ to a great degree as the magnitude of the ln value become larger. Okay, if this difference is like very high, then means after you convert to this, so you can see 0.18, 0.20. So not very, but if the difference will be very high, then definitely this number will be also very high. Okay, ma'am?
Okay, sir. Okay.
Sangeeta, is it understood?
Yes, sir.
Okay. So this is how you can plot it. And now you can see that is what it is saying. They have used Udry's. Okay. So you can see this is simple proportional change and this is continuous proportional change. And how they look different. So now what is it? Is intuition is giving intuition for this relationship is given by example involving compound interest. Suppose you have initial saving S0 and a guaranteed annual interest rate I, and we can write the formula for savings amount at year T depending on the discrete number of time per year N. That your interest earnings are compounded. So this will be our formula, isn't it? ST will be equal to S0 into 1 plus I divided by N to the power N into T. With annual compounding, N will be equal to 1. So this will become ST will be equal to S0
Okay.
into 1 plus
For quarterly,
I to the power t. With quarterly compounding, it will be s naught into
n
1
by
plus
4 la.
I divided by 4 to the power 4t. Okay. So when n tends to infinity, so that your interest earnings are continuously compounded, the formula for the saving amount will be st will be equal to s naught into e to the power rt. Okay, ma'am?
Okay, sir. Okay.
Is it clear? Why we will do e to the power rt? Because of continuous compounding.
Yes, sir. Yes, sir. Yes, sir.
So I think this much is there. Constant elasticity already we have studied, right? Now we can do some practice.
Yes, sir.
Let me see. This one already, I think you have already done it, right?
Delta YT is, yes, sir. Change in YT, yes, sir.
Today you did, na?
Mm.
This one I have not done. So we can do
We
this.
have taken,
This one also not very important, but what we can do is Bhaktivam, because we have already completed this one, review of mathematical tools. So there is one assignment based on this.
yes, sir.
So rather, when we will solve that assignment, so it will be much easier. Just give me 1 second, I will show you the assignment. Okay?
Okay, sir.
1 second. Because this assignment will be very interesting. Based on whatever we have discussed so far, yesterday and today, just give me a minute, ma'am.
Okay, sir. Okay.
One second. Let me show you 1 second. Just be there, ma'am.